Hello everyone, my name is Hunter, and today I'm going to try and explain how to comprehend division by zero. So let's start off with this graph. As we can see, we have 5 functions here, and each function has a numerator of 1, and each denominator has a number that is a decimal. The first one is x equals 1 over 1. Second equals x over 1 over a half, which is 2. The third is x equals 1 over a third, 3, x equals 1 over a quarter, x equals 1 over a fifth, and so on and so on. And as you can see, as each denominator gets smaller and smaller and closer to 0, the quotient increases. Now these are just going up by 1 each, but you can double them. You can keep going, and you can get numbers even further. You can get numbers bigger and bigger, and as you can see, the closer that denominator gets to 0, the higher the number you get. So if you keep going, what happens? Let's say you have x equals 1 over the decimal of 10 to the power of 100. You're still going all the way out. That number is still increasing. You can do this with any number, and it will just increase, 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 and increase. It will not stop increasing. So, what happens if you get to 0? It is marked as undefined. There is no function on this graph. I can scroll out as far as I want. Nothing will appear. Now, let's try and visualize the function as x equals 1 over 0 plus a number. Here, I added a half. So, we have 2. 0 plus 0.5 is the same as 1 over a half. So we are given 2. So, with this information, we can declare 2 things. If x equals a, which is any number that does not equal 0, then x will not be undefined. And 2, if x equals 0 or x equals any equation that equals 0, then x will be undefined. Now, hypothetically, let's say we have an equation where x equals 1 over z, whereas z is equivalent to the smallest number positive closest to 0. Here, z will equal 1 over 1 minus 0.9 repeating. In this situation, x equals positive a, or x equals a number that does not equal 0, so it will not be undefined. Now let's deal with negatives. Let's take a look. Do you notice anything different, other than the fact that the denominators are now negative? So are the quotients. And let's take a look at the positioning of the functions. If we take a look at the positive, we can see something interesting. With every positive denominator, we get a positive quotient. Now, of course, the numerator has to stay positive for the quotient to be positive, but we're focusing on the denominators. Right now, our numerators are just 1, and that's just a constant. The denominators, however, have changed value. And as you can see, it is a negative quotient. With these functions, all that's happened is by changing the value and changing it from a positive to a negative, the functions have all reflected across the y-axis. If we can have defined numbers which are below 0, where does that leave 0 itself? To come to a full conclusion on this, let's do one more test. Let's say, hypothetically, x equals 1 over y, whereas y, this time, is the closest negative number to 0. Y will equate to 1 over negative 1 plus 0.9 repeating. In this situation, x equals negative a, or x equals a number that does not equal 0, so it will not be undefined. Now, we're starting to see a pattern. When the denominator is positive, the function is placed to the right of the origin. But when the denominator is negative, the function is placed to the left of the origin. So, if we were to visualize x equals 1 divided by 0, where on the graph would the function be placed? Would it be a positive x, or would it be a negative x? Well, here comes a problem. We know 0 is nor a positive nor a negative number. This takes out both possibilities of being a negative or a positive x. So where would that leave it? We can look at this blank graph. If 1 over 0 cannot be to the right or to the left, and dividing by a number that cannot be nor positive or negative, what can that leave us with? Can that leave us with an answer that can also not be positive or negative? Would that mean that the only possible place to put this function is on the 0 itself? Let's also take into consideration that with our original realization that the smaller and smaller that the denominator gets, the larger the number gets. So what if you really did just make that number as close to 0 as you possibly can, and then you just pushed it over and made it 0? Well, wouldn't that be infinity? Let's think about it this way. Infinity is not a real number. Infinity is nor irrational either. Infinity cannot be visualized. Similar to I. I is not a real number either. I is an imaginary number. You cannot graph I. So with that, we can try to comprehend division by 0 as equivalent to 0 itself or infinity itself. Whether it be positive infinity or negative infinity, that is where I leave this.